Okay, so we're back, and by now you should have again created a scatter plot, a least squared regression line. You should have calculated that. The correlation and variance, again, you pull out the same screen as the least squared regression line, and also create a residual plot. Now, let's talk about what is a linear regression t-test. On this example here, we used a total of 5 fossils. 1, 2, 3, 4, 5. So our sample size was only 5. What this test here is called a linear regression t-test. This will actually consider every possible least squared regression line that could be calculated. For instance, imagine everyone in here right now had 5 separate fossils. That would be approximately 25 different least squared regression lines. What this equation will do is unite all those together, and we can come up with true population least squared regression lines, true intercept, and a true slope. Now you'll notice here, we call this the average of all the possible y's. That's why we use mu. Now here, we're going to use the true slope. We're going to use the letter Bravo for that, the letter beta, excuse me, and we're going to use the true intercept here as well. What we're going to do now is we can do this on the calculator. This is called, again, a linear regression t-test. It's under the test screen, just where all the other tests are. And when we do that, we're going to use a linear regression t-test right above here. It's the second from the bottom. Now our data is going to look like this. It'll ask for where's your data for the x, where's your data for the y, frequency, leave it as 1. You'll see here it has a little trouble writing the letter beta. Right now set it equal to 0 and then hit calculate. Now let me explain what we're going to do here as far as calculations. Ho represents the slope of the regression line. If the slope of the regression line is 0, in essence, that means there is no correlation. There is no comparison between these two. If we have ha, that says we do have some type of a regression. In most cases here, we'll set ho as beta. Again, beta is just Greek letter B, and we usually use B when we talk about here, this. Now we're going to say beta is for all possible least squared regression lines. Now when you hit calculate, your screen takes a long time to fill up. And we get all kinds of stuff. First of all, it tells us linear regression t-test, y equals a plus bx. Again, that's our least squared regression line. Now this p-value here is used in calculating the p-value that we'll eventually see here. Again, this is a p-value. Because it says e-4, this is basically saying p-value of 0. Extremely small. We will reject ho, and we will, in essence, accept ha. 3 degrees of freedom. Again, the degrees of freedom here is slightly different. Usually degrees of freedom is n-1. Here, it is going to be n-2. Now, they again gave us the A that we came up with before, the y-intercept. And they also write this down because for our sample, for my sample of 5 fossils, we came up with y hat equals 3.66 plus 1.197x. 3.66 plus 1.197x. That was my sample of 5. This number S I will explain in a moment. They again repeat a lot of the data. They give us R and R squared again. Now, this value here, S, what it's doing now is saying how much Y values will differ based on the same X. For instance, on my sample, I ended up with a least squared regression line. Now, one of you could have taken 5 different samples and come up with a different least squared regression line. This value here is more or less saying what possible error we might see in Y. For instance, we might take the same femur length And for instance, I might have a femur length. If x is a value, I might get a femur length. This was my data. I might get a humerus length of 10. What we're saying is, based on every possible least squared regression line, we might see from other data, using the same femur length, I would get of about 10 plus 1.98. So I might see about 11.98. So if our humerus length for my sample was 10, we might see other data have a humerus length of about 12. That's what this S value does. And you will see this one here in a moment on an AP question. Now, determining a confidence interval is different here. What we're going to do is we're going to have a confidence interval based on our slope. For this guy here, what we're going to do is the confidence interval is the same in essence. Again, margin of error is the T star and then SEB. Now, again, degrees of freedom will be n minus 2. We're going to use the T table again. SEB is the standard error in the slope. Standard error in the slope. And that's usually given to you in some type of a printout. And we're going to spend some time on that here in a moment. Now, we're going to go over 2 AP questions here. What I want you to do, there's one on the front and there's one on the back. What I want you to do at this time is to take approximately 3 minutes, and we're going to start on question number 2 first. What I want you to do at this time for question number 2 is read the problem and try to do part A. Now, to do part A, this right here and this right here are the key areas that we're looking at for part A. So take approximately 2 to 3 minutes, read through the problem. When you finish reading it, read it again, and then let's try to figure out the equation of the fitted regression line. And we'll come back together in a couple of minutes.